Hey there everybody, Joe here. Thanks for tuning in again. So I'm going to continue off of last week's video about color theory and, more importantly, using it in your painting. The first thing I'll talk about real quick is black. What is black? It's really just the absence of light that causes you to see black. So just like white is when all of the different colors are making all three of the sensors in your eye trigger at the same time. Well, black is just the opposite. You might have a full spectrum light, like what comes from the sun, that's displaying a lot more than just red, green, and blue. It's displaying red, orange, yellow, green, blue, violet, and everything in between. And so you still get a white response because there's only three sensors in your eye. So it's just a combination of those three to tell you what's going on. That's why a computer can do a good job of simulating that without actually emitting the exact same kind of light. So this is the color that I used on this end of my little rainbow here. It's the same. You know, if I put that on there, it'll start to dry right away and you'll see it getting darker. So let's get some more and do a demo here. So right here is the magenta over the top of white. So you can see here that you can get a really bright pink by using the magenta over the white. And now the same with the yellow. This is the yellow that's straight out of the can right here on my spectrum. So when I put the yellow on top of this white, it's allowing all of the yellow light that's in this white to shine through that yellow. And it's not allowing the, you know, these other frequencies, these other colors to shine through. And if it was, it would be a lot less yellow and a lot more white because it would be allowing all these to shine through. But it's bright because you're taking a bright white and backlighting this yellow. So you're getting a brighter background than what it had. So in this one, let's say this paint is literally like 100 tiny particles thick because those paint pigment particles are very tiny. So this is, you know, it has a depth. It's many particles thick. Well, so then you've got yellow behind yellow behind yellow. So behind each yellow particle is another yellow particle, and that's visible through each particle because they're transparent. So, you know, when you get to like so many particles thick, you don't see through it anymore. But when I just do a thin layer over white, now instead of seeing the yellow shine through the yellow, you're seeing the white shine through the yellow, and it's brighter. So it brightens up the yellow and keeps the nice saturated color. Same with this magenta. Same thing is happening, just with this, you know, red-violet hue instead of the yellow. You can make red. So you see, after I get this magenta thick enough, it starts to look red instead of orange. And so that's exactly how that system works. You know, it just, this red would be a secondary color in that system. Now, if I take my red paint, however, you're going to see that this paint, now I'm not going to put this real thin, I'm just going to put this paint, I'm going to put it thick enough that you can't see through it. I still have a more saturated red right here than what I have here because this is now a secondary color being made with two. And so the primary is always going to beat out the secondary. So here we go with putting this red right over the top of white. Let's compare that difference. This is a great way in any picture, you know, if you can put the color in a thin layer over the top of white, then you're going to get a real bright color. And that's what I use. That's the technique I use to get my very brightest results when I need to. So you can see that this red now makes this red look kind of brown. So I still am going to keep using my red, yellow, and blue system in painting, but it's good to have that understanding that there's a, you know, understanding the reason that the other systems exist and why they work the way they do. So likewise, if I put blue on top of this orange now, then it would turn into a very blackish kind of color, but it would be really more like a dark gray. And so that's why in the CMYK system they add a black, because the three dyes on top of each other don't get quite as black as a black pigment. To demonstrate why certain color frequencies will be allowed to come through a substance while others won't. I've got this fun little experiment. So a frequency is just how frequently an event happens. So I'm snapping at a frequency right now. And if I start snapping faster, well, this is a higher frequency. So color is, you know, it's that light, and it's bombarding an object at a certain frequency. So let's say a particle of light is coming every so often, and that's the frequency of that color. You've got your coffee in the morning, and you know, you have to stir it at this certain speed. So I go nice and quick little strokes to stir my coffee so that it doesn't spill over the edge, or I can go nice and slow like this. But there is a certain frequency right about here. Look how it's going in rhythm with the frequency that I'm stirring this. And so if this is a brighter light, well, look, it's just going to spill right over the edge. I mean, this object loves that frequency. It's going to respond to it and vibrate right in time with it. But then if I slow down a little bit, look what happened. It immediately killed that reaction, but it will have kind of a window, you know, any frequency between here, let's go a little slower. There's still a lot of activity happening right there. Now I'll go a little faster. There's still a lot of activity happening when I go a little faster. So you see, it's not only one exact frequency, it's just in that range. Let's say that we're at a slower frequency. This is a yellow now trying to shine through a blue object. Well, if I do this hard enough, yeah, it's going to shine through. You know, there's enough energy that's going to respond, but seeing the yellow through that blue is just going to cause it to appear as colorless white light, because you'll see the yellow and the blue at the same time. You just see it all through there. The point is that it's going to have a real nice saturated color when that one frequency shines through, but it filters out the others. This is going to get more red as light shines through it, and this is going to get more yellow as light shines through it. And then when it gets over here, it flip-flops. So this whole spectrum, everything moves toward the yellow as light shines through these different colored substances. It's that way with paint. It's that way with berries on bushes and pieces of plastic that you can see light through, and water, and all kinds of things that are these colors follow this pattern. This right here, this is just a straight blue and white mix. So this is literally becoming more green as I put white behind it, because it allows green and blue light to shine through this substance. So this is red and white piled up on top of each other and mixed in a batch. Okay, so now the next little color sample is going to be the red layered over the white instead of mixed with the white. So now you can see this one looks a lot more red, while this one is slightly more toward the magenta pink. Now, I know that the difference is not that extreme. What this experiment shows is that this red is really only letting the red light through. It's not allowing much of the yellow or violet through, and this magenta likewise is pretty much only allowing magenta color to be seen as I make it real transparent. So the blue is more like objects we see in nature that don't have such a restricted color that it allows to be seen when light shines through it. So and this also is a cool experiment, because this shows how red is really restrictive on only allowing red through. So of course when I mix it with my green or my blue, I'm going to get very dark colors, because the red is layering over that and won't allow those colors to be seen. In nature, things are a little bit more like the blue pattern, where the blue wave shows a little bit more green when it lights up. Now let's see why this even matters in painting. Okay, so let's say that you want to make something in your painting that doesn't look like it's completely opaque. You want to make it look like light shines through it. So let's start with a bright backlight. Let's paint some white. Now these are the leaves that are right up in direct sunlight that you can see through. You can see a lot of sunlight shining right through those leaves. So what I'm going to do is definitely add green, but keep it on the very yellowish green side. Now I'm not going to go crazy with details, I'm just going to put shapes on here, and we'll just say that those are leaves in the sunlight. Just like as light shines through, it's going toward the yellow as it gets brighter. So you remember the spectrum, the green's here, and it allows the yellow to shine through as it gets brighter. Well, as it gets darker, then I might just move a little bit toward the blue. And now if I want to make it look like light is bouncing off of these leaves and not shining through it, then I'm going to think of my light color wheel and think of additive color mixing. So where this we were considering the subtractive color mixing, where that green is removing colors from the white and the yellow is allowed to get through. Well, over here, I just want to combine white light with my green. That's simple. I'm just going to add white, and that is going to have a completely different effect. If I just have white highlights in here, it's going to be like edges of leaves that are popping out and catching the light. So now I have depth really quickly without having to paint any actual leaves, just by adding the white for areas that are the light's shining on it, and then using that bright yellow or green where the light is shining through it. And then I can add deep shadows too. That'll be fun. Here, let's go even darker. Without having to do any work with detail, I can give the feel of what's happening just by understanding the colors that would be there. So let's say this is grapevine, and now we're going to put a cluster of grapes. So I'm going to take this more red color and put it near this bottom, make a smaller circle near the bottom of these grapes. And if I wanted to get real detailed, I could try to blend it. Okay, so every time I get brighter with this, I'm going to also get a little more orange. Let's mix another layer, and this time I'll add just a little bit of yellow as it gets brighter. Little bit. Don't want to go crazy with that. Right, and then we'll just put that inside of the red. Now because this has that yellow hue, it immediately looks like light coming through these instead of light shining from this way and bouncing off. Alright, so now let's do some additive color, where we're going to just bounce this green light from these leaves off of the edge of that violet. Now, so with the light color wheel, remember that the opposite colors activate all three sensors and have your gray colorless response. So now I've got this yellow-green color here, which is, we'll kind of go, yeah, here it's the yellow-green where the sunlight is blasting through this and shining this color. And so right across this color wheel is the opposite color. That is my blue-violet. Well, my grapes are more over here, so since these aren't completely polar opposites on the color wheel, then I'm not going to use a complete gray. I'll use a gray that maybe is just a little bit on the orangish side right here, because if it was going straight across, I would just use gray. I didn't put the white or gray that would be in the middle of this wheel, sorry. Incomplete color wheel. But since these are right here, close to opposite but not, then that gray is going to have a little of the color that it's on the side of. So, okay, that looks good to me, right there. So now let's see if this actually looks like the green light reflecting off of the grape. There, now we have all of that green light from these leaves reflecting off of that violet grape by understanding additive color mixing. Let's say that there's just a little bit of skylight coming through. Okay, there you go. So that's why it matters. You know, all of that fancy explanation that I did really doesn't matter if it's not going to help you accomplish something. This is the knowledge that I have used to be able to do what I do, and that is exactly what I want to demonstrate, is that this is what works, this is how it's done. So I hope you find this helpful, and I'll look forward to the next video. Okay, first off here we have Skip Move is asking, how would I paint flowing water, not a waterfall, but like it's flowing over an edge? So there's real distinct current patterns in there where you know, imagine the waves bunching up. So if you have, you know, wave patterns coming down a river, when they hit a rock, they get real tight and close together. And whenever you have rain and you see the water washing down the curb on the side of the street, this is a really visible pattern because there's little pebbles in that. And you can learn a lot by looking at that. The waves bunch up and then they fan out as they come around that rock. And so when they fan out, they crisscross the waves that are fanning out from other rocks also. And so you have crisscross patterns, but instead of being more level like in my How to Paint Ripples video, they are, you know, a little more like this. And so if you're able to map those out by sketching the lines, thank you for buying that How to Paint Water series that I have. That helps me out a lot when people purchase those video sets that I have available at learn.muraljoe.com. Next we have, hello, my name is Lean and I'm from Holland. How does it work for underwater scenery when some colors fade or are no longer visible at all? Will it become shades of blue and black then? Right, great questions. Yeah, the answer is yes, you have it right. Just like my failed experiment with the red on the white, remember? Where it was only letting the red light through as the white is shining through. Well, same with deep blue water. When you get down low enough in that water, the other colors are less and less visible that are not the color of that water. So while you still can see light when you get down deep, you start to see only the color of the substance the deeper it gets. That's really valuable to know for doing underwater scenes. You really want to restrict the contrast of the colors and keep them all a lot more in that family of the color of the atmosphere. Real heavy atmosphere effect in underwater scenes. Here's another good comment from Paula Ellis. You live in Arizona but paint the ocean. Do you just look online for pictures? Or do you just come up with it from memory? Well, it's both. I definitely research lots of pictures. You know, I just go to Google and I have it right here. You know, and I just put beach wave. Here, let's just do it here. Beach wave. You gotta be careful what you put into a Google search. And then I'll spend hours doing this, just looking at these pictures. And when I see one that interests me, ooh, that's a cool picture right there. Okay, and then I study, see what's happening, and I just see if I understand everything that's happening. This is how I study. And then I go to another one I think is cool. Oh, okay, that's cool. What's happening here? What's causing those colors? I see sky coming through. I see the edges that face this way are reflecting that, but you know, there's certain patterns. I'll look for every pattern that I can explain. Anything I can't explain, it's like a stop sign. Whoa, what is that? I gotta learn that. And that's how I study, and I get used to seeing the shape. So then what I do is I invent my own picture, typically, and then make sure that it fits with all of the things that I studied and that it meets the guidelines, so it's a very believable picture. And so while I study photo after photo after photo for each project, I'm working from my memory based on what I've just studied. No matter how much I think I know how to draw a form, there's always some new little detail to add, so I always do the studying before the project. Even though I could do it from memory and do a decent looking picture, you know, like the grapes that I just now did. It's gonna look better if I look at 1,000 pictures of grapes first. So I just always do that. Okay, here Dominic Jones brings up a good point. Is water blue just because of the blue reflection, or is there something else? And I'm simplifying, but to the best of my knowledge, water really is blue. I mean, when you see pictures from outer space, there's a big blue ocean, and I think that that's more than just because of the blue sky that's surrounding it. And whenever I look at especially clean water in massive amounts, it always seems to be blue. Now, I know that it's very transparent in small amounts, but I don't know, maybe it has similar similar molecules as atmosphere, right? Oxygen, hydrogen, I don't know. Maybe those things are blue. I'm not an expert on that. But I do think that water actually is blue. It just has to be a large enough quantity to actually see that. I also think that there's a lot of materials in water a lot of the time that also are blue in appearance and can make it even bluer. So that's about it for my knowledge on why water is blue. But as far as I can tell, it really is blue, and even bluer than the sky a lot of the time when you're looking at seascapes. In like a lake where there's maybe dirt in there and not a lot of sun bouncing off of bright sand, then the darkness overpowers the blue. So I think water is slightly blue. I like this comment here. Denise says, "At last I understand. I used to dress windows and use sailboards in fluorescent red. When I looked away, I saw green. Now I know why." And then Shed's channel painted fluoro signs a lot in my job, and the same thing happens when I use chartreuse. Turn away and see red. It's good for strategy in paintings when you put those opposite colors next to each other, like turquoise and red or orange and blue. Then one causes the other not to seem brighter, but to literally appear more the color, because it deadens your senses to the colors that the other one doesn't have. So the orange deadens your senses to the orange, and then you see the blue that much brighter. I just think that's a super cool effect that happens in painting. It's fun to use, that high contrast. Okay, I'm gonna stop there for now, and I hope you can tune in next week, and I'll look forward to seeing you then.